State mass balance problem. Here we'll do some mass balance in a mixing tank. Then from this mass balance we'll get single order first order ODE, and then we'll solve that problem by using RK4 method. Now here problem is a tank contains 850 kg of solution at 25 degrees centigrade. From the inlet, sugar solution at 25 degrees centigrade flows into the tank at a flow rate of 20 kg per minute, and from the outlet 15 kg per minute sugar solution is coming out from the tank. After 2 minutes, what will be the amount of sugar solution? And solution concentration is uniform everywhere. Now this is a tank and that one inlet is there. So from this inlet 20 kg per minute sugar solution is coming and 15 kg per minute sugar solution is coming out. Initially sugar solution is 850 kg is there inside the tank. Now after 2 minutes, what will be the sugar solution? So what will be the total amount of sugar solution in the tank? So we have to calculate that by using RK4 method and Euler method. So first problem, question number 1, do mass balance to obtain ordinary differential equation. Second, after 2 minutes, what will be the total amount of sugar solution in the tank by using RK4 method and Euler method. Basically here this problem I will solve by hand calculation, and then see same thing we'll do by MATLAB code, and also we'll validate that MATLAB code with ODE 45 inbuilt function, and then we'll plot everything, and then we'll get what will be the sugar solution after 2 minutes. So these are the problem, and we have to solve that. Now first here we have to solve this problem, means we have to do the mass balance. And we'll get that ODE. Now here assumption is liquid is perfectly mixed. Okay, means the concentration is everywhere. Now mass balance equation, we know general mass balance equation is rate of mass accumulation is equal to rate of mass input minus rate of mass output plus rate of mass generation minus rate of mass consumption. As inside the tank there is no chemical reaction is going on, so rate of mass generation and rate of consumption will be 0 or neglected. So now the equation will be rate of mass accumulation is equal to rate of mass input minus rate of mass output. Now what will be the rate of mass accumulation? So rate we know that is d by dt, and then mass accumulation, so d dt of m is the rate of mass accumulation. Rate of mass input already there 20 kg per minute, so that is 20 kg per minute, and then rate of mass output, so that is 50 kg per minute. Okay, and then together if we write, so what will be the equation? dm by dt is equal to 20 minus 5 is equal to 5. So dm by dt is equal to 5. Now the condition is at t is equal to 0, that m is 850 kg, means initially 850 kg sugar solution in the tank. Now after t is equal to 2 minutes, so what will be the m? So that we have to solve. And solution strategy: solve ordinary differential equation by using RK4 method, Euler method and MATLAB inbuilt function. Also this very simple ODE we can solve by analytical also. So if we do the analytical solution, so dm by dt is equal to 5. Now dm is equal to 5 dt, and then we have to do the integration. So at t is equal to 0, then t is equal to 0, m equal to, okay, so here so t is equal to 0, just a minute, okay, so t is equal to 0, m is equal to 850. Now t is equal to 2 minutes, what will be the m, right? So that we have to calculate. So m, if we do the integration, so 850 to m, okay, is equal to 5t, that is 0 to 2. Now m minus 850 is equal to 5 into 2, so that is 10 minus 0, so that m will be 860 kg, means after 2 minutes what is the answer? So 860 kg. Now we have to solve this problem by using RK4 ordered method. So how do you do that? So we know that RK4 method we can write, just I take that one ODE. So dy by dx is equal to f of xy. So now here y of 0 is equal to y0. So that is given. Now by using RK4 order method, so that is we know yi plus 1 is equal to yi 1 by 6 k1 plus 2 k2 plus 2 k3 plus k4 into h. Now k1 is nothing but f of xi yi, k2 is equal to f of xi plus half of h, yi plus half of k1h, k3 means these are the slope. Now if we average that, we will get the next step of the y. So that k2 is f of xi plus half of h, yi plus half of k1h, k3 f of xi plus half of h, yi plus half of k2h, k4 is equal to f xi plus h, yi plus k3h. First we have to calculate k1, k2, k3 and k4, and then we can take the all the slope and take the average, and we will get the step size of yi. Now here this equation is one dependent variable and one independent variable. Now in our case, so our ODE is dm by dt, that is equal to 5 and m0 is equal to 850. Now here if we and we have to calculate m2, means at t is equal to 2, what will be the m? If we use RK4 order method, so mi plus 1 is equal to mi plus 1 by 6 k1 plus 2 k2 plus 2 k3 plus k4 into h. Now k1 is equal to ti mi, k2 is equal to f of ti plus half of h mi plus half of k1h, k3 f of ti plus half of h mi is plus half k2h, and k4 f of ti plus h mi plus k3h, and ti plus 1 is ti plus h. So this is the fourth order Runge-Kutta method. Now we have to implement that. Now here we know that m0 means here that is given m0 at m as t0, that m is equal to 850, that we know. Now first we have to calculate k1. K1 is equal to, so now iteration number 1. Okay, so here I is equal to 0. Then after calculating, it will be I is equal to I plus 1. So now if we calculate k1, k1 is equal to f t0 m0. So that is f of 0 850. As it is a constant value, so 5 will come. Now k2 similarly f t0 plus half of h, m0 plus half of k1h. Now we have to plug all these value. So t0 is 0, then half that is half h, so half is there, and h is here we are taking h is equal to 1. So for hand calculation we can take h is equal to 1, but otherwise we have to take different step, means we have to do the lot of iteration. And for program, if we do the MATLAB program, h can be very small, and we can do that. Now here 0 plus half into 1, and then m0 here is 850, then half k1 is 5 into 1. Now if you do that, so f of 0.5 and 852.5. Now as that function value is constant, so again we will get the 5. Similarly k3 and k4 we will get, so as constant value 5. I will show another problem in that when we will calculate simultaneous ODE. So then how this k1, k3, k2, k3, k4 varies, so I will show you there. Now we can easily calculate m1, means m0 plus 1. So m0 1 by 6 k1 plus 2 k2 plus 2 k3 plus k4 into h. So we can easily get that 855. So what will be the t? So t0 plus 1 is equal to t0 plus h, and 0 plus 1, so that will be 1. So at we know, so this is the initial condition, m at 0 is equal to 850, m that 1, so that will be 855. Now if we do another step, so we will get the answer. So iteration 2, similar way. So now k1 will be f of t1 m1. So t1 is 1 and m1 is 850. Now again that is the constant value, because we know dm by dt is equal to, actually 5 is equal to f of t and m. So that is constant value. Again we will get constant value 5. Similarly k2, k3 and k4 we can get same, but we have to calculate f of that t and m. So that we will get in the different step when we calculate k2, k3, k4. So this value will be different, but as that dm by dt is equal to constant, so we'll every time k1, k2, k3 everywhere we will get 5. Now if we do again, if we want to calculate m1 plus 1 means m2, m1 plus half of this average, so again we will get that 850 plus 5, so 860. Now that is actually matching with the analytical. So t1 plus 1 is equal to t1 plus h. T1 is 1 and h is 1, so that is 2. So m of 0, so that is 850, m of 1 855, m of 2, so that is 260. And analytically also we got that m of 2 is 860, so that is matching. So now we understood hand calculation RK4 method. Now if we go Euler method, so we know that yi plus 1 is equal to yi plus hfxi yi, and ti plus 1 is equal to ti plus h. So it is simple than RK4 method. Now we know m0 initial condition 850. Now we have to calculate m2 is equal to 1. Again h is equal to taken 1. Okay, and then we can calculate. So m0 plus 1 will be m0 plus h into f t0 m0. Now t0 m0 means what? 850 plus 1 into f of 0, t0 value is 1, t0, and m0 value is 850. So again we will get 850 and this is the constant value, means if we put here, so t and m, so we will get 5, right? So then we will get that 850. So t0 plus 1, t0 plus h, so that will be 1. So that will be t is equal to 1, m1 will be 855. Now iteration 2, m1 plus 1, m1 plus hf t1 m1, so 855 plus again 1 into f1 t855. So again that this is the constant value is equal to 5, so that we can plug this value and we get 860. So and t1 plus 1, t1 plus h, so that 1 plus 1 2. So ultimately by Euler method also we get m at 0, that is 850, m of 1 855, m of 2 860. Now I'll show you how to calculate in MATLAB. So MATLAB, I will write code for RK4, Euler, and inbuilt function. Inbuilt function, that is ODE 45. That will get same answer. Now for that MATLAB we can take h very small and then we can do the iteration. Okay, so after doing the mass balance, what we got, that dm by dt is equal to 5, and at t is equal to 0, m is equal to 850 kg. At t is equal to t, and that is t is equal to 2 minutes, what will be the m? And we will solve by using RK4 method, Euler method, and MATLAB inbuilt function by using MATLAB. Now how to do that? So now here I'm using Octave, but Octave and MATLAB commands are the same, so you can use that. Okay, now here all these data are there. So first I'm clearing the data, CLC. Now here that we know that dm by dt is equal to 5, so that is function of t and m. So this ti is actually 0, that is initial time, mi is 850, that is initial mass in the tank, and tf is equal to 2.0, that is final time, h is equal to 0.1, that is time step, and here I am calculating the number of steps. So until 16 tf minus ti by h, so because n is integer, so this is not a float, and then I am calculating the m by using Euler method. So t is equal to ti, so generic variable m is equal to mi. Now here m for storing purpose, so this is required for storing the value, storing the value. Okay, so and this is also store the value of t. Now initially we just store, so at m1 what will be the that m and t, and then coming to the Euler method, so m is equal to m plus h plus f into tm, and t is equal to t plus h. So similar things we did here, so that is for Euler method we did that. So m plus 1 is equal to mi h plus h into f t I m, so that we did here. Okay, that is the Euler method. Similarly, for RK method, again we are taking all this value n is equal to intel. Similar thing, again storing purpose. Now here I am calculating k1, k2, k1 is equal to like that. So here, not this, here for Euler method, that k1, k2, k3, k4 and m. So that here we are calculating k is equal to f t0 m0. Okay, so that tm k2 that ft0 0.5 into h, m0 5 into k1h, k3 ft plus 0.5 into h, m 0.5 into k2h. So first k1, k2, k3 and k4, then m is equal to m plus h by 6 into k1 plus 2 into k2 plus k3 plus k4, and t is equal to t plus h. That means we are here using for loop, because we are calculating h at every iteration. And inbuilt function we also do that. So already that function is written here, and then we can call for inbuilt function means we use ODE45. So t and m, so that is after calculating after iteration what will be the t and m is equal to ODE45. Then we are calling the function, and here 0 to 0.0 to 2 is that time span. In that span we have to means that MATLAB will calculate what will be the value of m, and this is the initial condition, right? And then if we run, and then after all getting all this value, so we can plot that. Plot first t Euler versus m Euler, then t RK4 versus m RK4, and then t analytic, not analytical, t ODE45 and m ODE45, and then title is solution of the equation, time t, y level solution m, lesion m Euler, m RK4, m ODE. Now if I run that, then what will be the, if I run, I will get, so here we can see that for m Euler, m RK and m ODE, these are giving the similar region, and after 2 minutes, so the result is 860. So these are the code for RK4 as well as Euler method.